Hello everyone, good evening. Dear authors and invited guests, welcome to technical session 2C. I'm Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation and Knowledge Chamber of Commerce and Industry, welcome you all to the 7th International Conference on ICT for Sustainable and Development through Zoom. I hope this session was informative enough. There's a special note for the presenters that you will be given 8 minutes for the presentation and 2 minutes for the question and answers. On the 7 minutes, I will be raised a gentle reminder to conclude your presentation. And there's another request for all the presenters that you will be stay connected with us. There's a closing remarks. And just before we get started, I would like to introduce you all to the chair for the session, Professor Nilesh Popol-Sable. Sir Sable is an associate professor and working as a head of the department in computer engineering in Vishwakarma Institute of Information and Technology, Savitribai Phule, Pune University, India. He has 13 plus years of academic experience in field of computer engineering and more than 40 research publications at national and international journals and conferences. His research domain includes IoT, data science, and data mining.
Good evening, sir.
Good evening, sir. Thank you, sir. Okay, now I'd like to start with the papers. Our first presenter is Priya Maitri, and she's presenting on survey on various IoT-based irrigation techniques in India.
Good evening, everyone. Am I audible?
Yes.
Yes, ma'am.
Yeah. So let's start with sharing the screen first. So my topic for today's conference paper presentation is it is a survey paper that is doing the analysis of various IoT-based irrigation techniques that has been used in India. So basically, the introduction is related to the first is the farming. What is we know that in India, the agriculture is a prime source of a land of a livelihood for around 58% of Indian people. So if we use modern technologies that we have nowadays for agriculture also, it will improve the productivity of agriculture as well as its value chain. So there are various technologies has been introduced, just like the IoT. Basically, the IoT is the IoT solution makes the farming as in smart farming nowadays. So the what is mean by actual an internet of things in agriculture. So IoT is just like a network of physical objects and the software applications which has been reside in either in the cloud or in systems which is use some machine learning or artificial intelligence algorithm for doing the predictions related to the farming. So that is the way we use the Internet of Things in our agricultural sectors. So here in agriculture sectors, the different technologies that we use, which are based on IoT, are robotics. So basically, the robotics in our agriculture we use for weed controls, where we have the weeds in the fields that has been detected with the robotics. Then analysis of soil analysis, temperature analysis, then monitoring of the field will be done with the robotics. Along with that, we have the agricultural drones. Drones are basically used for monitoring the crop and its production, the growth. That way, we use the drones also, which is one of the IoT technology that we have in the agricultural. Then we use the IoT technology in the smart greenhouses also, where we can analyze or we have the sensors that has been used for sensing the and monitoring the greenhouse temperature, the soil moisture, and based on that we can do the irrigation in this greenhouse. We can increase or decrease the temperature which has been required for the crops inside the greenhouse. Then along with that we have the remote sensing. So remote sensing is basically we use the remote sensors that we plant inside the field and outside the field, even with the with the digital cameras and all, we can capture the photos, and we use these images for monitoring the health of crops. And based on these analysis, we can do the predictions for the further improvement in the crops. And computer imaging is also one of the part, just like as I've told you that we can capture the images from the satellite also, or we can use the cloud services also for capturing the images of the fields, and based on the analysis of those image, we can do the prediction for improvement in the crop productions. So these are the different technologies that we use in the agriculture that are based on IoT. So in the survey paper, I have that we have analyzed 6 methods over here. 6 papers we have analyzed. Then does the analysis of 6 papers, in which the first one is automated irrigation system using a Wi-Fi. So here you can see that in the diagram, the physical devices that has been used are shown over here, and the application, the software application that has been used is a web page which has been connected with all the sensors through the Wi-Fi, that is the wireless network we have. All the sensors will send the information, the data that is related to the temperature, the soil moisture, then humidity inside the air, and this kind of the features, or you can say this kind of a factors related to the farming, different fact levels of the farm field has been given, sent to the application through this node MCU microcontroller. So all this data has been sent through Wi-Fi to the application, and in application we have the different machine learning algorithms can be used, like the decision making trees we have, or the classifier we have, pattern recognition we have. So based on that, the analysis will be done. In this system, they have been used the supervised learning, where we have the training data in which they have written for a different values of humidity, temperature, and soil moisture, what kind of a predictions will be there, whether we have to do the water supply for the field or not, that has been decided within this way, the using the supervised pattern matching algorithm. And then the second we have is the smart plant watering system, where the cloud analysis and plant health prediction will be done based on the cloud analysis. In this technique, the watering to the field has been decided with the help of plant health. Plant health will be decided with the analysis of moisture level of a soil, temperature, and the pH balance level of the soil. These values has been sensed with the different sensors that have been projected in the fields, and based on the plant health prediction will be done, and based on the plant health, the water supply has been given to the field. The third one we have is automated smart irrigation system, and this system we have, as shown in the figure, we have the data set that we have taken, and the sensors will be there which are used for data collection. They have been planted inside the field, and along with the drone also we can have the image and capture also. And along with that, in this specific system, they are using ARIMA, that is AR is the auto regression integrated moving averages. So here we have the analysis will be done with the ARIMA technique, and in this the recognition will be done based, or the final decision will be done based on the TDMA over here. So here you can see that ARIMA is the technique they have been using, where they are taking the average of every factor they are getting, the data they are getting from the, in terms of a series of values has been given over here, taken over here from this, and average has been calculated, and that average value of every factor will be taken as an input for getting the final decision. Here also they are using the decision tree algorithm for finding out whether they have to provide the water supply to field or not. After this, we have the one more technique where the system, the device setting has been a different way, will be done in a different way. In this drip irrigation system, using the wireless network, they have every sensors has been installed in different area, but there is a one sync node which is responsible for collecting all the data from the sensor. So this sync node use the multi-hop protocol, and the hopping of getting the data from these sensors has been done based on the priority. So they have given the priority for every sensor they have been installed in the field, and based on the multi-hopping protocol, they are getting the data from every sensors, and the data is used for analysis. After every step-by-step analysis, the final decision has been made whether they have to give the water supply for the field or not. And the next one we have is it is the again here also they have been using the cloud system for sensing the data. Cloud system has been used. Field in the field, the sensors has been installed, from which we are getting the data. All the data that we have got from the sensors has been sent to the cloud, where the analysis has been done, not only with the data that has been collected from the field. Along with that, they're using the weather forecasting weather forecasting system is also collaborated with the same, and based on both the systems, they are finding out the result. They are giving the result, or they are predicting whether they have to give the supply for the watering or not. So that way, this smart farming technique has been used, in which, along with the sensor, the data that has been collected with the sensors, they are also using the weather forecasting system also for the water supply. Then the last one we have, that is the smart drip irrigation, in which you can see that on the hardware level, we have the YUN microcontroller, which is responsible for collecting the data as well as for sending the water supply to the field. This is having a buzzer also, which will give the intimation for the person, the responsible person related to the water supply, if there is any uh,
Sorry to interrupt you, but we have
problems.
last 1 minute.
Yeah, problems will be there in the communication. All the data from the sensors has been sensor has been sent to this Arnido YUN, and then we have the node MCU, which is a microcontroller which collect all the data, and it will communicate with the cloud, where he will get the data from related to the forecasting also, and the prediction will be done based on it, and that will be sent to the desk to the application layer, that is the user who is responsible for uh, doing the actions or taking the actions related to this irrigation. So that way we have the all 6 papers over here, which I have been analyzed, and based on this, some limitations has been identified in these techniques. Like the first technique which I have told, which I've discussed, that is too much costly for the large lands. Then the second one we had is not mentioned, not included any weather forecasting. So it may be have there will be a failure of the system if there will be a heavy rainfall or a surprising rainfall will be there. Then we have the automated smart irrigation system. In this also, if there will be a wrong weather forecasting will be happen, as there is a continuous water supply has been given. So it may be do the excess water supply has been given to the farms if there will be a wrong forecasting. Similar to this, the next also have the wrong weather forecasting will also have the excess water supply has been given to the farmer. So, and then the next one we have is the IoT based automated irrigation system, in which the solar energy has been used for the system, and there is a lot of maintenance required for the WSN network, and if there will be a faulty detection will be happened. So that is what the limitation in the as in gaps in the system we have for this. And again, the last one is also as it is in combination of weather forecasting has been used as is not used in this the last one. So it may give you the wrong prediction from the system. So this is how we have done the survey for the all these papers. So in the resultant discussion, I just want to say that in the traditional way of farming is now changing day by getting the higher technology. Like we are getting the very good sensor devices which can be used for such a IoT based application, where we get the more and more accuracy after getting nowadays, when we are using these applications, the data set is going to be increased more and more after the other. So with the use of these IoT applications, we can improve the farming also with the help of modern technology. And these are the references that I have been used for referring. Thank you.
Okay. Madam, can you precisely state the findings, major findings that you have found? Major findings, huh? If you want to state any one finding, what is the major finding from this?
So basically, most of the systems have been using the decision tree algorithm and supervised algorithm, where they have been used the already decided pH level balance, humidity, and all. And they're using this data for analyzing, and then they're doing the prediction for the water supply has to be given to the soil field or not. So that is what the finding I have done. And one more thing that I have added in the limitations, that either they're using this prediction has been done based on the values that they have got from the sensor, or they are using the weather forecasting, the data that getting from the weather forecasting system. And once yes, sir.
Have you included some sort of future work into your paper?
Right now I've did the survey, sir. Actually, that is the proposed system. I am just working on it. So that will be the combination of both, that is weather forecasting along with this the data that we get from the field. And along with that, actually we are currently we are implementing two combination of machine learning algorithm, that is the decision tree, and one more is the machine learning algorithm that we are going to use in the combination to finding the prediction for that.
Okay, madam. Thank you.
Okay, thank you.
Okay, so our next presenter is Hfss Prajapati, and he's presenting on classification of attractiveness of clothing using convolutional neural network.
Hello. Am I audible?
Yes, you are.
Okay. Good evening, everyone who is present here. I am Hfss Prajapati, and I recently completed my Bachelor's of Engineering. Our research paper title is Classification of Attractiveness of Clothing Using Convolutional Neural Network. We prepared this research paper under the guidance of Professor Sagar Patel and Professor Jaimin Dave. So this is the abstract of our project and research work. We all know that with the advancement in technology and trends, it is very important to be updated with the latest trends. A consumer wants good quality products with different design, and this process is very tedious because it will take a lot of time to find out good product from plethora of products. So that's why online shopping has taken such a hike, enabling users to cancel out the long process. But due to changes in trends, consumers fail to buy product according to market flow. This problem has motivated us to make a recommendation system where the user can click an image or use an image in their gallery to find out the attractiveness of jeans and top. The project works by taking input from the user. That input is then passed to a model, which recognizes the details of the picture and compares it with the existing database and shows how attractive is the clothing, specifically topwear and jeans. So next is dataset design. We wanted to build our own dataset. So we collected around 5,000 screenshots of different type of jeans and topwear for males and females. These screenshots were collected from top selling e-commerce websites like Amazon, Flipkart, Ajio, and many more. So this is the sample of our dataset. We also renamed all the images from one, so it will be easy for us to count and process these images. So to collect database from users, we create Google Forms, which include each and every screenshot. We ask the user for details about their profession, gender, age, and location. We circulated our Google Forms in different colleges and collected our data from students, teachers, family members, society members, and local businessmen and vendors. So this is the sample of our Google Form which we circulated. So after collecting all the data from the users, we started data preprocessing. For that process, first we combine all the responses which we collected from the users, and then we use EDA methods for cleaning and preprocessing our data. We also implemented one program to generate the path of each and every image from Google Drive, where we have stored our data. So here you can see this is the sheet where we collected every image path with its label and image number. And these are the data that we collected from users. In this sheet, there are all the details of customers are available. So this is the workflow of our model. So this is how our model works. First, we collected images, then we collected ratings for that image from users. After that, we use data preprocessing methods. Then we extract the features from the images, and then we split our database into test image and train images. For model building, we use 2 convolution layers and 2 max pooling layers with 2 different filters, which can be used for extracting important information from the images. After this layer, we use dense layer that combines 700 neurons in the first layer and 10 neurons in the second layer, which gives us 10 outputs from 0 to 9. We also compare our CNN model with the artificial neural network. So then we find out CNN accuracy is high and it will give us accurate prediction as compared to ANN. So we have used CNN instead of ANN. So this is the implementation and result of our model. This confusion metric compares the actual values with the predicted values. So it is visualize and summarize the performance of our model. So here you can see that the actual output which we have got from our model and with its actual rating along with its prediction. Besides the CNN model, we also integrated our model into Android application. So this is the workflow of our application. And here you can see the user interface of our application. And our application is also available on the Google Play Store. So next is our future work. We are planning to implement a dynamic database. So if any user insert a picture in our app, that picture is added to our database. So our database size will increase and we get better prediction. After changing our base model, we can also use a new model to find out the attractiveness of any objects like monuments, furniture, human face, and many more according to our requirements. So in the conclusion, this technology shows a promising result in many fields. It will help industries and manufacturers to build the product according to the market flow or trend so that there is less wastage of resources and better scale for the product. It will also help customers to be familiar with the trend and buy accordingly. Thank you.
In pre-processing, which features you have extracted?
Sir, in data pre-processing, we extracted user's age, which is very important for us because we are extracted from age 18 to 30, and we separate it out. So we get better prediction according to age.
Only age, that's it.
Yes, sir, age and if a user enter any specification like what they like in a cloth image like fitting, texture, color, this information is also added.
Why you have preferred ANN, CNN? Any specific reason?
Sir, we compared both the models and we find out that CNN is better for accurate prediction, and it will give us high accuracy as compared to ANN. So CNN is also very preferable for image classification.
Okay. What if you want to choose an alternative for CNN? Which algorithms are available?
Sir, we are working on it, and we are trying to find out on which algorithm we find more accurate predictions after that.
Okay. CNN, whether what it is, supervised, unsupervised, what it is?
Sir, we supervised because we collected data from users and then we pre-process all that.
Okay, fine.
Oh,
thank you.
Thank you. Thank you.
Our next presenter is Jihan Mehra, and he's presenting on analyzing impact of online advertisement using internet on consumer buying behavior. With special reference to mobile phone during COVID-19 and pre-COVID-19 period. Thanks, he's not here. Moving for our next presenter. Alok Bhagwat, and he's presenting on indigenous electric population system for Indian Navy step towards Atmanirbharta and low emissions.
Yeah, good evening, session chair. Am I audible, sir?
Yes, sir, you are. Please start.
Okay.
Yes, you are.
Thank
Yes.
you so much. I'll just share my screen. Is the screen visible, sir?
Not yet.
No, 1 minute. Yeah. Now,
Yes, it's visible now.
okay. My topic is indigenous electric propulsion system for Indian Navy, which helps us in reaching toward Atmanirbharta as well as low emission. The guide is Dr. Pradnya Chitrao. These are the presentation scope. Actually, we read in the open literature also that Indian Navy is pursuing indigenous shipbuilding very aggressively. There are very few ships which we are buying now from abroad. We are building mostly in our shipyards only. In the very recent past, there are these 3 projects, 6 submarines, it's called P-75. I leave the name, 4 ships of landing type where helicopters will land, and 7 destroyers. These are under process. Now, my topic is basically concerning how you are procuring the equipment, whether you are considering the life cycle cost. Normally, we say what is the cost of buying the equipment, and that's about it. But that does not reflect the true expenditure which Navy eventually incurs. Point number 1. Point number 2, there are technologies we may have in civil industry, but not in the defense. So we have to partner with a global leader under technology transfer model. These are some of the images of the ships which will be built under these 3 projects. So it has been seen, and somewhere in the past there were some papers we have also written where it came out that the acquisition cost is quite low compared to the operation and maintenance cost, because the ship gets operated for 25 years. We are aware, aircraft carrier or destroyer. So that is where this show that if we consider only acquisition cost, we are not actually budgeting for full, and later we end up paying more. So life cycle cost is acquisition and operation and maintenance. And it has also been seen that if we consider life cycle cost, then an Indian supplier become competitive because his cost for supporting our own Navy is very, very low. So this is the relevance. Literature review, in fact, a couple of papers have been written by us earlier also, where we had, that's why you find only few references. This particular paper had considered a lot how life cycle management is done in the global Navy, advanced navies, US Navy, NATO navies and all, how we can implement it in the Indian Navy. So what is the research gap is that life cycle management is not followed by Navy. Life cycle costs are not considered when we decide L1 is who is the lowest amongst all. Second, Indian Navy, Indian defense suppliers, including the big names like Tata Group, Larsen and Toubro, Mahindra, Kalyani Group, nobody has experience of electric propulsion because Navy does not have an electric propulsion as of now. They will be going in for now. Therefore, there is no clear roadmap for guiding Indian suppliers how they can follow so that they can become the supplier of these equipment. So the objectives are evaluate feasibility for manufacturing electric propulsion equipment. Actually, electric propulsion equipment is nothing. It is not, we are not touching the technical aspect. It is a motor which is driving the shaft. We all know the ship is driven by a shaft and propeller. Instead of engine driving it directly, it is a motor which drive. So you have to control the speed of the motor. And we are talking very high power motors, 5 megawatt, 6 megawatt and all. Therefore, the complexity comes in. Second is carry out a cash flow analysis. When an Indian manufacturer is manufacturing, is it economically viable or not? And third is, if yes, how does he go about doing it for the first time? Thereafter, the repetition can be done. The methodology used is exploratory and descriptive research. The primary data collection was done by focus group survey. In each area, the Navy's design team, the shipyard who build his equipment, the equipment suppliers who supply to Navy, including Indian and foreign suppliers. So a group of such senior people were selected. Thereafter, a Google form was circulated to them and their responses were obtained. The areas covered was what is the potential, commercial potential for these three ships, which how will be the cash flow analysis, and what is the comparison between the, if we go for a indigenous model for outright import. So the survey question address, what is the market potential, what kind of project schedule, what is the R&D expenditure required because we'll be doing for first time, how are the cash flow. So this is one of the example of one of the area where the commercial potential, it came out that for these three projects, the potential is roughly of the order of 2000 crores. So the value is quite big. And the schedule which emerged was that R&D has to be done in 4 to 5 years. That is by 2026 or so. Your technology transfer, what will be the work share between the technology leader and the Indian OEM should be done. And thereafter, the equipment delivery will begin in 28 and go on till 37. So roughly, we are looking at 150 to 200 crore potential every year. The developmental cost, it came out that approximately 150 crore will have to be invested for the development, which will involve TOT agreement, design and engineering team setting up, facility setup for doing the assembly testing, qualification by Navy by year 2023, so that you are allowed to take part in the tendering. The first order will come in 2026 and the delivery of the first equipment will be 2 years thereafter and cycle is 10 years. Now, this is the interesting part. If we do not consider the life cycle costs, then the cash flow looks like it. You have got, I have taken only one project, which is the landing dock of 4 ships. So you will get the first delivery here. So 100, 100, 100. You will continue to spend from 2026 onward 15 crore rupees per annum on the manpower. The facility cost, even if you go it under the that mode of depreciation and all, this will be like this. Material roughly contains 60%, so you will spend here. So if you see in the first year, you will make a loss. All figures in the bracket are loss. So overall, the project does not become viable because the very fact reason is that a foreign supplier has already got the technology developed, so he doesn't have any R&D and facility setup cost. But if we involve the spare support for 25 years, the training setup which has to be done ashore for training the team, for repair setup, and thereafter for 25-year deputation for scheduled and breakdown maintenance, which is on a payment basis. Incidentally, if it is a foreign supplier, we have to pay him in foreign exchange in any case. And there will be upgrade because electronic component gets obsoleted. So this is where, when we say that if life cycle management is brought in, will it become viable? The majority of responses was they were agreeing with this. And the cost now, if you see, same. Now you will get the annual maintenance contract revenues also because the supplier is responsible for maintaining. After warranty period, Navy starts paying you. So this is roughly what you will earn out of the annual maintenance contract. Manpower cost is same. Now here, since you have a contract for a longer duration, you can amortize the facility and TOT cost over a longer period. And now if you see, in few years, you may be incurring a loss, but overall cumulative, if you see, you will break even here and make some money. And once you have the technology developed, you can go for exports also. That is the policy of the Indian government now. So the clearly 57% says that if if we, and in addition to this, we are not included the cost of the repair, and for which Navy will be paying you. So what is the conclusion is the Indian manufacturer can supply electric propulsion equipment under TOT with a global leader. TOT route is essential because the 4 years, 5 years, it will be difficult to do a ab initio development. Defense manufacturer, the survey showed that Indian manufacturer do have the capability. Global leaders are willing to partner with the Indian firm, but the life cycle cost must be included. And with life cycle cost, the money project become commercially viable. And there are many advantages with Indian OEM because saving in foreign exchange during the supportability for 25 years. This can be exported, and back to back, there is a lot of ancillary industry also get a support in this. So the recommendation is life cycle cost should form the basis. Incidentally, successive the defense acquisition policies are addressing, but there are still some gaps. That is where the effort is to get those gaps bridged specifically for this technology, for which we will see the ships being built in the next decade or so. And Navy should move to a life cycle management as is seen for in the US Navy or the advanced navies. Future scope is prepare a roadmap for guiding Indian industry to get qualified and manufacture this equipment. Interact with Navy so that whatever is the gap in moving toward the life cycle management, those get bridged in time so that Indian manufacturer can participate in these 3 ships, and interaction with Navy for laying down the life cycle management. These are the references. That's it from me. Thank you so much.
Nilesh, you have any question for the presenter?
I just have one curious question. Like as sir have proposed that this sort of huge investment needs to be done, how you can justify that it will prove?
Actually, if you look at the trend, that is what Indian companies are doing. Gradually, we have started building even like radars, the guns. L&T has built guns for army under technology transfer from a South Korean firm. Lot of radar new technologies, even the new one in the artificial intelligence area or in the drone manufacture is coming from Israel. So that is where I shown the 2 tables. If you consider that what is the cost of supply, then no, you can't make it. It will not be viable. But if you consider that continued revenue will come for maintenance, so what will happen with this? As I did a survey of which are the firms who can do it. They are already supplying small power motor to Navy. So once they know that 150 crore investment is not a big for companies like Larsen and Toubro, Tata Group, or Bharat Forge, Mahindra, they are doing such kind of investment. I was with L&T for 15 years, so I have seen that kind of. Only thing is, Navy there should be a commitment that they will recover the money. So 150 crore development is not a big. They already have the facility and all. Only the motor testing and all area will have to be brought in.
Okay. Okay. Thank you. Thank you.
Thank you, sir.
Okay, that's it from my side. Thank you, sir.
Okay, our next presenter is Dr. Sai Saran Prasapati, and who is presenting on artificial intelligence in game programming.
Yes, sir. Good afternoon. Good evening, everyone. This is Sharwan. So, is my screen visible, sir? Hello.
Yes, it is.
Yeah. So, my title is my project is artificial intelligence in game programming. It was done by Venkat sir, me, Sarvepalli Mohit, Syed Afzal Ahmed, under the guidance of our faculty, Dr. Natarajan. So, coming to the abstract, we know as a child we played a lot of games and we're constantly seeing the evolution in the video games. And what's the most interesting aspect that has changed over the time is animations and graphic quality, of course. But and what made the games more interactive is the development in the NPC characters. AI has played a bigger part in this. And what made the game even more realistic is the game physics. So it has brought even more interesting and interactive environments to the game. Even if it's a virtual world, if it has a well-defined construct and a logic like physics, it can be more realistic for the player. So what we're trying to do in this project is to create some smart AI characters that think strategically and logically and navigate through the environment, all while avoiding the obstacles and pursuing the goals you give them. So, and we try to maintain the physics and animation systems together with the behavior and states of your game in the in-game characters. This will enable them to interact with the world and with the players physically and visually correct. And AI has been introduced the video game from the beginning, like it has been in the from the 1990s, starting with enemy tracking systems like enemy and player coordination systems. Those can also be taken as a basic AI. But these days, it's for the few decades, it's we can see immense growth in them. Like there have been more open world games and everything, and where we even a small character is more interactive. But that has not been progressed so much. Like it has been done, but within a similar pattern only. Not like everything will have its own AI minds. So the game that we have been worked on comes under the FPS category, which is a first-person shooting category, in which there will be player and the set of zombies, and we try to create 8 zombies with 8 different personalities, and which even to show that even in a single themed game, that if we have different behavioral characters, it will give a game a new interactive way. And while having a different types of zombies, it is so important to see player feels the difference between each other. And as most game bots are built up upon a rigid system with number decisions and animations, it can be seen in a similar pattern, but with small management between them, it can be interactive as well. And like I said, there will be zombies, so there are horde of zombies coming towards us when we run in the environment course, which is interactive to defend ourselves and attack at the same time. This has been the perspective of the game. To further zombies pattern and everything, we are using A-star algorithm and Namesh agents for our NPC characters for the goal to avoiding the obstacles, which is as some anything. So the hardware and software requirements, because it's all done in Unity. Unity is a very big software which requires a minimum RAM of 8 GB to compile and run a game, and minimum 6-core processor, at least a integrated graphics controls, animations, and interactive features, and then getting into the play. So then there are 2 types of characters in my project, like zombie and a player. And there are 8 types of zombies we used. And each zombie has a different behaviors, and each zombies have basically two different types of triggers, which will activate the pre-ordered traversal that has been set for the animated controls for the zombies. That is sound trigger and the light trigger. The sound is made by the player, and the light, since it's going to be in a dark environment, a small point source of light will be with the player as form of flashlight, and it will also act as a trigger for the zombies. In the methodologies as adopted, we have mostly used all the tools from the Unity, which has been inbuilt for like cameras, effects, and A-star algorithm for navigation. And the most important thing is the Unity trigger systems. That is a very useful kit that Unity has created. And application managers and collectible items. Collectible items is for making the environment so interactive, and character manager and FPS controllers and audio mixer from the Unity. And audio mixer enables to add specific audio files to the scenes or the movements or to the players or any object in the Unity. So as I said, there will be different types of animator controls. Let me say if the zombie has 3 types of locomotions. like undamaged locomotion, damaged locomotion, and crawling locomotion. And it has 6 types of states, and hit states, and regular attack states, crawling state, fighting state, and all these feeding state. And each state has different types of animator controls. And these are all linked using the state mission controllers in the Unity. So these are the zombie waypoints. It is a very small bit of a plane, but we created for checking. And these are all the waypoints that zombie can run through the course. And these waypoints will be, selecting of waypoints will be done using the A-star algorithm. And as I said, there will be triggers. These triggers are guided to the colliders into the characters. So like this is a zombie character shown, and each part, like a hand, a body, everything has a damage taking aspect, since so that every part will be taken as collider, and each has a trigger systems, and the radius of the trigger system can be changed, and it can be varied. Like for a sound or light, the radius should be bigger than the damage taking aspects. And these are the, as I said, the environment would be interactive. You can see different types of objects that are all interactable in these in this small bit of a plane. So coming to the results, it is no doubt from the beginning that EA makes the game more interesting and closer to the reality. The experience we got while testing multiple features on Zombie made it clear that more as an NPC is described, the more it is interesting. With multiple NPC in the game, the player doesn't feel the game seam all the time. So there are few questions that has raised while creating our project, and like a priority order traversal during states, and how an interactive scene has multiple audio mixers in it. And it has been done using audio mixer tool in the Unity, and change in state of trigger systems. As I said, there are many states for each trigger system. There will be a priority order traversal, and it will be changing all the time during the game, which will give zombie orders. Like if there is a sensation called feeding and attacking, if a zombie is full, it will go on attacking mode. But if it is sad, it will go on to recovering mode, and it will prioritize the feeding. It will change continuously during the game based on the player. So how, and most of the times when you play games, you can see the NPC characters would be idle. So how not to make it idle? So just a simple thing. Assign it a follow pattern, and if give it a ideal state motion, like not ideal state motion, give it a some process that should do in when it's ideal. So in that way, it doesn't look idle. So these kind of NPCs shows practically that even the game with general character with similar theme with different personalities add multiple variations to the gameplay and play style. This type of NPCs can also be used to make the test data for the generative models for generating unique NPCs. So eyesight, hearing triggers, and all of these variables in the NPC will make it look more realistic, adding to the physics of the game. And with the fast development of emerging interaction and AI technologies, especially the emergence of concepts, hybrid intelligence, AI techniques are taking step further towards a more prosperous future. So coming to the future work, to be honest, these days, nowadays, the construction of NPCs is in a crude way. Like it takes a lot of storage, and each game can go up to 200 GB or 300 GB. If it has a lot of NPCs in the character, since it has a high resolution, it's going to run on a high resolutions, and it takes a lot of RAM. So it's not working in a better way in the lower specs systems. We should work on that. But coming for an idea for the future work, I think we can use generative models for creating bulk number of preset NPC characters, or create NPC character. They just support to or anti to the player, like we do in the deep fake data training, fake data training sessions, we can just give a preset set of preset constructs, and we can use a deepfake for creating generative models. I think this will be used in open world scenarios where there will be a lot of open world interactive characters, and using generative models, then no need to create everything specific. It can be created using AI. So these are the references we have used. That's it, sir.
Okay. Can you go to result slide? Hello, am I audible?
Yes, sir. Yes, sir. Yes, sir.
What means? Yeah, can you just state in one line what are your contributions?
So this is a type of review paper based on our project we have done in college
Yeah,
to
yeah.
show.
It is a review pattern, but there are some findings, right? On
Ah.
which you can go forward for any sort of work. So what are that
Yeah.
findings?
So there are some types of idle character. There are some types of NPCs that look idle in the game, but what we done is assign some pattern, assign some position or some waypoints in which it will move from point to point, and which it will does not make it look like idle. Or this will make these kind of some small preset things for the NPCs will make it look more interactive. Not interactive, it does not make the character look like an NPC.
Okay, fine. That's it. Thank you.
Okay, so moving to our next presentation. Slit is ready, and she is presenting on design and analysis of metamaterial waveguide antenna for broadband applications. Dear
Yes,
presenter, you may
yes.
please start your presentation.
Yes, I'm presenting, sir.
Harry sir, can you show the presenter slide? 1 second.
Sir.
Okay.
Sir,
fine.
actually, here it is written you cannot start screen share while the other participant
Just a
sharing.
second, while I stop to screen sharing. Now we can start it.
Okay, sir. Sir, it is visible.
Yes, it is. Please make it full screen.
Yes, sir, I have done, sir. Full screen.
No, it's not. It's actually showing the other side also.
So actually, sir, I have done here. It is showing, sir. 1 minute.
Press
Sir.
F5. Press F5. Control F5.
Yes, sir. Now it is coming, sir.
Not yet.
It's okay, you continue.
Okay, sir. So I'm Smriti Dwivedi. I'm from Department of Electronics Engineering, Indian Institute of Technology, BHU Varanasi. Now today I'm going to present my paper on the topic of design and analysis of metamaterial waveguide antenna for broadband application. So under this topic, I'm going to cover, these are outlines. So these are basically a definition of metamaterial and introduction, then how does it work, then how many types of metamaterial we have, and now the basic structure which I'm using, like SRR structure, design of my structure, results, discussion, conclusion, and references. So before going to start, what is metamaterial? So metamaterial is basically a engineered material. We cannot get material like a conventional material that we have, like copper, aluminum. We cannot get this material in our environment. This is basically a engineered material which we form or which we made by using a change in shape, geometry, size, orientation, as well as arrangement of the atom inside the material. So using these type of changes, we get the metamaterial. So we are having a different types of metamaterial according to the permittivity and the permeability of the material. So we are having a double positive material, epsilon negative material, double negative material and mu negative material. So these are basically depending on if we are having a negative permittivity or if we are having a negative permeability, then we get the property of metamaterial. So basically we are using a Snell law to calculate the refractive index of the metamaterial, and basically for metamaterial we are having a -1 refractive index because we are having a negative permittivity as well as negative permeability, and both are in complex number. So different types of metamaterial we are having, like initially we are having a split ring resonator which is called SRR structure, and then we have a conducting post as well as some wire that we use for the metamaterial structure by changing its shape, size, orientation as well as arrangement inside that material or the atom of the material. Now SRR material or the split ring resonator, this is a basic structure that we use for the design of metamaterial. Now this material has a property that we can work up to 200 terahertz. So we can operate or we can use this material for very high frequency which is in terahertz. Now we are having a single SRR or double SRR depending of our requirement. If we are going to use a lossless type of system, we are going to form a lossless type of system, then we go for a double SRR or the more than double SRR. So we are having a different type of SRR structure that we can see here in the below in this slide. In the below you can see that we are having a double SRR structure, that we are having two different rings here. Now we are having a different types of SRR that we are going to use in our design. So we are having a edge couple SRR, square broadside couple SRR, complementary broadside SRR, that is we are going to use in our structure. Then we are having a split SRR and square SRR, and then square edge side couple SRR. So these are basically I have designed using a simulation software which is known as a Hfss, which is a high frequency structure simulation. So that software I have used to design these type of structure. Now microwave metamaterial, basically we deals with the different types of metamaterial, like we are having a 1D material and we are having a 2D material by affecting the epsilon as well as the permeability of the structure. So how we can change the permeability or the epsilon or the permittivity of the structure? By changing the model of the structure or by changing the periodicity of the structure. Also we can change the inductive effect as well as capacitive effect of the structure, and then we get the 1D and 2D fabrication of this structure. So there are different types of structure that we use by changing the inductance as well as the capacitance of the structure, and we can get the easy type of metamaterial. Now again we are having a different types of microwave metamaterial, like tunable metamaterial, where we can easily change the frequency of metamaterial by changing the capacitance value of the structure. Like we know that the frequency is inversely proportional to the capacitance. So if we are increasing the value of capacitance, we will have a less frequency. So we need to change the capacitor every time to change the frequency, because we are having a gap inside the SRR structure. So that gap actually creates a capacitance between the gap. So that capacitance value we can change by changing the frequency according to our requirement. Now again we are having a type of metamaterial as well as the perfect lens type of metamaterial. Now the advantage of metamaterial, like we can use this metamaterial nowadays. So many uses of metamaterial, like to design the antenna for 5G as well as 6G application, we can go for a metamaterial structure. Apart from that, we are having an optical filter, medical devices, aerospace. There are so many applications area we have there. We can go for metamaterial, as well as metamaterial is 3D structure. If we use a 2D structure of metamaterial, that is called a meta surfaces. So we can go any one of the structure. Now the equivalent circuit of Bcsr, like broadside complementary SRR. So this structure, so I'm audible.
Yes, you are. Yes.
Okay. So for equivalent circuit of Bcsr, I am going to use this structure. Basically, this is called a broadside complementary SRR. So if we are having this is decided according to the radiation pattern. If you are having a vertical radiation pattern, we can say that this is a broadside radiation pattern. And if we are having a horizontal radiation pattern, so that is called a A side SRR. So here we are using a broadside complementary SRR. So you can see here that we are having two different types of SRR, double SRR and single SRR. Single SRR means we are having a single ring, and you can easily see there is a gap in this ring. Now the first one is a double SRR, means we are using a 2 SRR structure, and again we are creating a gap to change the capacitance value. You can also see the equivalent circuit of these double SRR and single SRR. Now the structure that I am using for this is an experimental setup type of structure that I am going to use for my structure, even though I am not doing I have not done any experiment because I don't have a terahertz frequency range. But of course simulation and analysis part I have done using a CST Micro Studio as well as the MATLAB coding. Now this is the design parameters for my metamaterial waveguide antenna. So basically I am having a waveguide structure. Inside that waveguide I am creating a metamaterial shape. So for that particular shape I am using that shape for the antenna purpose or for the radiation purpose. So this type of antenna we can use for the 5G applications very easily. So these are the parameters that I have used, like a radius as well as the waveguide radius, waveguide parameter, transition waveguide, height of substrate, and I am using the substrate here which is a RT toroid. So this is basically a dielectric for the metamaterial waveguide antenna. Now the proposed design I have used, you can see easily in the bottom of this slide that I am having a schematic view of metamaterial waveguide antenna. So the first one is the front view and the second one is the back view. So in the second one, back view, you can easily see I am using a single SRR structure which is a broadside type of, and I'm creating a gap in every structure. So this structure is basically designed inside the waveguide. Now I'm using two more waveguide. One is the left side and one is in the right side. So one, according to the frequency range, I have used these waveguides in this structure. Now the results and discussion. So basically, this is a unique feature material to design a SRR. So I'm using a negative permittivity and negative permeability to create this structure. So first I designed, then I have checked using the CST Micro Studio that I'm getting the negative permittivity or negative permeability. Then I have used this material for this structure. So the first one is the Hfss model for this structure. So I have used basically 3 different types of waveguide, and in the middle waveguide I am creating a metamaterial structure. Now the second diagram is basically epsilon and mu plot for the metamaterial structure. Now this is the results. So the first one is surface current, what type of current. So the first one is the contour plot. The topmost is the contour plot as well as a vector plot for the current that I am getting. So current means I am talking about the surface current that I am getting after exciting the antenna. So we have different types of excitation. Here I am using the coaxial feeding to excite the antenna. So this is the surface current that I am getting on the upper side of the layer. So the topmost is the surface current, and the below one is the radiation pattern that I am getting in the middle structure. So in middle structure I am having a metamaterial that basically I am using to radiate or to use as an antenna. So this is the radiating pattern, and then I am having a power flow that I am getting in the bottom structure. So basically what I have done, I have designed the antenna using a metamaterial as well as waveguide both. We know that waveguide is basically metallic structure, but if you are going to increase the frequency for waveguide structure, there is a problem because this is a bulky structure. So what I have done, I'm using only the X-band type of waveguide, which is 8 to 12 gigahertz, and then I'm creating a metamaterial structure inside that waveguide so that we can use that structure for the high frequency operation. So for this particular structure, I'm getting the return loss minus 30 dB and VSWR is 1.2. Now this can be also improved by improving the coupling between a X-band and C-band waveguide. So the gain of this antenna is 10 dBi. So dBi like a decibel reference with the isotropic antenna. It has a potential application values in antenna as well as imaging system, remote sensor, and radiometer. So these are the references, and this is the. Okay, sir. Any questions, sir? I'm audible, sir?
Yeah. Yes. You are audible and good presentation. Now, are you working on it?
Yes, sir. I'm working on it. I'm basically from microwave field, sir.
Okay. Okay. Now at what stage your research is?
Actually, sir, I'm working as an assistant professor in IIT BHU.
ITHU. Okay. Okay. Fine. Good.
Yes.
Good. No questions from my side. Thank you.
Okay, sir.
Thank you.
Okay. I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. And I hope this session was informative enough. On behalf of whole team, thank you for your support and supporting during this session and the previous version of the conference. And we will happy to have you in the 8th version of the conference in 2023. Also, all the presenters will be getting their digital certificates through email within 2 working days, and all the papers have been already forwarded to the stringer. The publication will be live within 5 to 6 months, so kindly cooperate with the team ICT4SD 2022. And I also thank our session chair for chairing the session.
Thank you, sir.
And so there is a token of appreciation to the chair on behalf of team ICT4SD 2022 and Global Knowledge Research Foundation.
Thank you, sir.
Thank you for your valuable presentation.
Thank you.
And now I would like to request you all to turn on your camera for a quick snapshot of the conference. Thank you. Thank you all.
Thank you. Thank you, sir. Thank you. Can I leave?
Yes, sir.
Okay.